Okay. So let me grab some gloves. So what I have set up is we're always, when we do our Qual, when you come in to the lab, we're always going to use a hot water bath in Qual. So you would get a beaker and fill it with deionized water. And then I don't know if you can make out that I have some little chips down here. They look like maybe tiny little pebbles. Those are boiling chips or marble chips. And so I'll have a couple of these in each of your fume hoods when we do the experiment. So that way you can put them in your boiling hot water bath, and they just are give a smoother boil. So it just doesn't, I'm going to put tubes in here and I don't want them bumping all over the place. So it gives a smoother boil. So that's what I have in there, because I'm going to need some hot water to dissolve the lead chromate in a few minutes. So I have that. I cranked it up. It was boiling, but then I turned it down a little bit. Okay, so what I'm doing is I have step 1. And so step 1 says to take about 3 mils of the known solution. So we will be putting these things in centrifuge tubes, and I have about 4 mils. So again, we're not doing careful measurements here. So 3 or 4 mils is fine for what we need today. And it says that we're going to add 0.5 mils of HCl dropwise, and we're going to observe a precipitate form. And it says to add until no more precipitate appears to form. Well, that's kind of tricky to do. And that's why we'll have another step where we check for complete precipitation. So 6 molar HCl, I color coded it yellow for this tube here. So we are going to, I'm just double checking, 0.5 mils. So how many drops would I add for 0.5 mils?
10.
10, because a mil is about 20 drops for these. So let me hold this up, see what we observe. So added 10 drops, and I could see precipitate forming, just kept forming as I added it. But now it's going to be kind of hard to see if more forms because it's all cloudy throughout. And I actually forgot that I wanted us to write down observations. So this is the group 1 I put it in the centrifuge tube. Okay, so the next step is to mix it up, vortex it. So let me show you, I think Professor Mikichi showed you the vortexer, right? But essentially wherever you're at in the lab, at least this kind of will help us maybe see. If you kind of turn around, there's going to be a bench behind you, and then here's the vortexer. So you just push in the middle and mix it all up. I'd say 10 seconds is good. I mean, this is obviously mixing it very well. So then what you're going to do is centrifuge. So the next part is centrifuge. So here's our centrifuge. It's usually up here, but I brought it down just so we could see it better. And I already did this. I already centrifuged. I'll show you because we'll be doing some more later. So it's kind of like a cooking show. So here I balanced it. So I had, so see right here, I have 1 tube, and then across from it, I have another tube. So this one I labeled, right, step 1. So now you can see the precipitate at the bottom of the tube, and the supernatant's clear. So I have a clear supernatant and that precipitate. And then this is just water. So I just labeled this tube water, and it's just an equal volume to balance it out. So I'm just going to leave this over here to use as a balance. Okay. So I've centrifuged it. I did that for us earlier, so we don't have to wait for that because we'll be having to wait for a few centrifuges. So what I'm going to do, I believe the next step is to add to the precipitate. Oh no, sorry, wrong step. We're going to add drops. So we're going to add some more HCl to see if I get any new precipitate forming. So I'm going to add a drop, and we want to look to see if I have any white forming in this clear supernatant. Okay, so that was step 1B, testing for complete precipitation. So here's my tube. Here's my 6 molar HCl, being very careful that I'm adding the right stuff because I did mess up on Tuesday. So I'm gonna look, I don't know how well it'll be able to show up. So I'm adding it in, I'm seeing it go in, but I'm not seeing like white cloudiness appear all of a sudden. So I'd say that we have complete precipitation. So now I am on step 1C. I'm going to decant the supernatant liquid into a clean test tube. If we're going to be testing through groups 2 through 5, but remember I'm not, so I'm actually going to dump this into my waste beaker because I don't need it. That would be if we were doing at the end of the semester, the one that contains everything. So always, you should also have a waste beaker. So I have a beaker here that I labeled waste. So we'll collect everything in the waste beaker, which will then dump in the waste container at the end of the experiment. So I don't need this, but again, I want to be careful. I don't want to throw it away unless I'm sure, and I'm sure that I don't need this. Okay, so I'm going to get rid of it. So see how I just kind of poured it out? The liquid came out and the precipitate's still at the bottom. There's also a little tiny bit of liquid. That's why we have to wash stuff, because I do have some liquid there. So we need to wash this precipitate. I'm on step 1D. Please follow along, in your procedures as well. So step 1D on page 44, wash the precipitate twice by adding 10 drops of cold deionized water, stir, centrifuge, and decant. So I have to do that twice. I have to have water. So I'm going to have, you guys will have a bottle of water that I'm going to wash. So I'm going to put 10, I put a little more than 10 drops. So 10 drops of water, but that's okay. And then I'm going to stir, vortex, and then I'm going to centrifuge. Okay, so like I said, we'll see our centrifuge a few times. So vortex, we're giving it a bath. We're getting rid of stuff. Okay, so vortex, I want to make sure I have a balance. Right now, this is not balanced. This has a lot more water, so I'm going to pour off some of this water. And I want to get approximately the same amount. So that was a little too much. So I'm just going to fill it up a little bit. And I'm going to place this in my centrifuge across so it's balanced. I'm going to close the lid. And then 1 minute at 400 RPMs. I know you can't, let me see, turn this here. See if you can see this. So 1 minute, 400 RPMs, and I'm going to hit start. So we have a minute. So, okay, so it's important to never open the centrifuge when it's spinning. You need to wait till it's done. You're lucky because these are new. We used to have these old ones that were just like terrible. So this is awesome. These are brand new. They work so much better. So that's good. So you can see it slowing down. And we'll get ready for step 2. So step 2 says prepare a boiling water bath, which I do. And I'm going to add 4 mils of deionized water to the precipitate from step 1D, which is this, and heat the mixture in the boiling water bath for at least 3 minutes, stirring constantly. So I need to grab a couple things that I forgot to grab. So I'm going to do that really quick. I should have done that. So this is my water. This is my precipitate that I washed. So again, it's stuck to the bottom. I'm going to get rid of the wash. I don't need the wash. I'm confident I can throw that out. And I do need to grab something from the back. Thought I grabbed everything, but I forgot a couple things. So waste container. I'm going to pour my waste in here. So what I needed to grab is glass stir rod. So these you'll have in your lab drawer. I forgot to grab it. I don't have a drawer. And a dropper, because we need 10 drops of hot water, right? So it says that we're going to add 4 mils. Oh, sorry, 4 mils. So that is a lot more than 10 drops. So we're going to add 4 mils. So I'm just going to look on this little centrifuge tubes. There's markings. So I'm just going to add hot water until I get about 4 mils. And then what we want to do is heat it up in the boiling water bath for 3 minutes, stirring constantly. So this is very important. This is the step that students, when they have to do this, mess up. So I'm going to make sure I do this carefully. So here's my hot water. I am going to add just water. So I know I don't have a glove on that hand, but And of course, the dropper I grabbed is not the best. Oh, there we go. Okay, so I have 4 mils in there. I just used the volume. And I'm first going to actually vortex it, and then I'm going to heat it. So I'm just using the vortexer to mix it. And then I'm going to put it back in the hot water bath. And then I am going to use a stirring rod. So I'm getting a clean stir rod, needs to be clean. And I am just going to mix. So well, let's see, 135. Okay. So I know you have 3 minutes. So again, if you want to multitask, you can be looking over some of those notes or maybe peeking at some of those problems while I do this. But it's really important to mix the whole time. So I'm just like using the stir rod and just like agitating it.
In the beaker of water, is that DI water or tap water?
DI water. That's why, yeah, I put it with DI water because I knew I was going to use some of it. Yeah, it's just always use DI water for sure. So what's happening here is we're trying to dissolve the lead to chloride precipitate because it is soluble in hot water. So that's what we're doing.
Is the temperature of your hot plate at 370?
Yeah, that doesn't mean anything really. It's just I crank it up so it's boiling. I want this to be boiling. So see how I see bubbles on the bottom. So it doesn't really mean anything really. I just want to make sure it's boiling. I actually turn it up a little bit to see if so I just want like a boiling water bath. So I see it's boiling gently, which is good actually. So I don't want to turn it up too much. Yeah, I want as much. So the reason we want to really stir is I want as much of the lead chloride to dissolve as possible because we want to get rid of all of it. So if I do a good job now, that's good because I'm going to have to wash. And I've seen students wash their precipitate like 20 times and they don't get the lead out. I don't understand what they're doing. So if we follow the instructions and really, do what it says, it should only take a couple washes. Okay, so after this 3 minutes, I need to centrifuge quickly and decant the hot supernatant into a clean test tube. So I'm going to be ready to do that. So I am going to, it's been almost 3 minutes. I'm going to leave that there for a second. Grab my balance. And I need to remember I have about 4 mils in that because I added about 4 mils hot water. So I wanted this to be around 4 mils, my balance. Okay, so I'm going to get that ready. Okay, give it. And I think once I pull it out, I'm going to do a quick vortex of it. That way to mix it up really good before I centrifuge. So I'm going to do this quickly. So sorry if the camera angles aren't the best. Okay, so now I'm going to centrifuge. So I'm going to hit start. There we go. There we go. So beep. So should beep, centrifuge it, and then I'm gonna get ready for the next step, which we're going to decant into a clean tube. It says test tube, we'll use centrifuge tube. Set aside any remaining precipitate for further analysis. So I don't want to get rid of the precipitate. So I'm gonna be ready to pour it into a tube that I've already labeled 2B, step 2B supernatant. And this new centrifuge is cool. The lid pops open when it's done. Okay, so quickly, I'm gonna pour this out. And I'm gonna set this aside. I don't wanna throw it out. And just to remind myself, 3 drops acetic acid. So 3 drops acetic acid. 1, oops, that was about 4, came out fast. Some of the bottles are faster than others. And then how many drops did we say for this one? It's 3 to 4. Okay. Okay, so we want to be watching this. So if you're not paying attention, please. 1, 2, 3. Do we see that? What do we get? Yellow cloudy. You see the yellow cloudy?
Yes, I see yellow cloudy.
Okay, thank you. So I describe this as Big Bird yellow. I know Gran was a Cookie Monster the other day, so we've got Big Bird yellow or Canary yellow. I don't know. Precipitate, and it's cloudy. That means precipitate. All right. So what does that mean? What do we have present?
Lead 2.
Lead 2. So that's good. That came out the way we wanted it. So I'm done with this one because it's at the end of a branch. I'm going to fill in my observations in a second on my here with you guys, but let's get to the next stuff. So that way we're not, I'm not wasting your guys' precious time. So I'm going to set this one aside because I don't need it anymore. Put it back here. And I am going to go on to step 3. And it says, if lead was present, which of course it was, we are going to wash the precipitate from step 2B with 4 mils DI water. And if lead is not present, skip to step 3B. Heat the solution for 3 to 4 minutes. Stir it several times. So similar idea. So I'm going to use, it doesn't say hot water, but I'm going to use hot water because I'm going to heat it up anyways. So I'm taking my precipitate. It is now precipitate from step 2B. So I'm just going to relabel it just to be, because this was step 1A, but I'm going to relabel this 2B just so I know where I'm at. So that if I have questions of myself, I'll remember. So I'm going to do the 4 mils. Yeah, 4 mils DI water. I'm going to do hot again. It could be cool, but I think hot's better because we're going to heat it up anyways. Got like the worst dropper on the planet, I think. There we go. Okay, so I'm gonna put the hot water. I'm gonna vortex it. And then I'm gonna put it back in the hot water bath. And I grabbed 2. You should have 2 stir bars. I'm gonna grab a clean one because this other one that I had in there before is contaminated. So I'm either gonna clean it or grab a clean stirring rod. And I'm going to do this again. So again, while you're waiting, you want to go over notes, read over the stuff in the lab, whatever. So do some chemistry stuff while you're waiting. And actually, I'm going to stir the solution. So I'm going to do it like this because it says several times every minute. Well, I'm going to keep doing this. In about a minute, I'm going to take it out and vortex it. Then I'm going to put it back. And then after a minute, I'm going to vortex it. So I'm going to kind of, get some good mixing going on with the vortexer in between. So the procedures, if you're reading along, it wants me to do this twice. So like I'm going to do this washing, and then I'm going to centrifuge and decant, and then I'm going to wash it again. Because usually we have to wash it at least twice. Because I'm trying to get all the lead out, right? Getting the lead ion, the lead chloride out of here. I want my precipitate to just be the silver chloride and the mercury chloride. Okay, so I'm going to take it out for a minute and vortex it. Vortexing is a good idea because some of that stuff, the precipitate gets stuck in the bottom of the tube, of the centrifuge tube, and it's hard to mix. So that's why I'm going to take it out and vortex it every so often. Okay, and I have about 4 mils again, so my balance should work. Close it, start. Okay, so we'll fill in more when I centrifuge again. So I'm gonna decant this into the waste because I don't need it, it's my wash. Washes always can be thrown out. So if I'm washing something, we will throw out the bath water, but we don't wanna throw out the baby, the precipitate with the bath water. So I'm throwing out my wash. And then I'm doing the same thing again. So I am going to add 4 mils of hot water, deionized.
So we're doing step 3A, is that right? Step 3A.
I'm still washing. Yes. So yeah, 3A still, because it says to do it, add 4 more mils. I'm at the very bottom. So I'm going to vortex this. Just really want to make sure the bottom you can get stuff stuck in there. So I really vortexed it. I'm going to stick it in the hot water bath. I need to do a couple things right now. See how my hot water bath, like it's kind of, it's evaporating. So that's why I'm cranking this up, because I am going to add some more water. So I should have done that a minute ago. Okay, so then I just added some more water. I also want to rinse off my stir rods with some deionized water. So I'm just going to rinse that into the waste. And I'm going to actually give it a wipe with a Kim wipe or paper towel. Because I am going to mix it more. Yes, so this is step 3A. So I've added the 4 more mils of the water and heat with stirring for 3 to 4 minutes again. And I'm going to be vortexing it a few times just to make sure I really rinse it. But after this wash, it is a wash, but we're going to decant it into a clean centrifuge tubes, and we're going to test to see if we have any lead ions. So we're hoping that they're all gone. Supernatant, or I guess it's actually, yeah, so actually it's step 3A, technically. Give this, I'm going to pour it into here because I have this one ready. And I then will test by adding the acetic acid and the potassium chromate. So here's that white precipitate that I was washing. That's the silver chloride and mercury chloride. And I am going to pour this in. So I have my clear supernatant. I still have my precipitate here. I don't want to throw this out. We might have to wash it again. We'll see. So I'm going to take my, 3 to 4 drops of acetic acid, 3 to 4 drops of acetic acid, and 2 to 3 drops of potassium chromate. Do we see any cloudiness form, or does it look clear?
Looks a bit clear.
Yeah, it looks pretty clear to me. I think that test tube, I didn't see, because if you remember the other one, remember when I added it, it just went cloudy right away. So this looks clear to me. So it's yellow, but clear, right? It's not colorless and clear. It's yellow and clear. So I'd say we don't have to wash it again. So sometimes students repeat that washing like 10 times and I don't know what they're doing. I honestly don't know, because every time I do it, if I wash it twice, like I just showed you, it always works. Looks to be good. So if I would have got that cloudiness, then I would wash the precipitate, this precipitate again. Does that make sense? Okay. So I'm going to follow, I don't need this. I'm done. This is just my test to make sure I got the lead out. So I'm going to dump this out because I don't need it into my waste beaker. My waste beaker precipitated because it had other stuff in it. I don't know if you can see that, but that's because there's other stuff in there. So I am going to move on then. And I now am on step 3B. So to the precipitate that contains no lead. So we washed all the lead off. Add 2 mils 6 molar NH3 and stir well. Carefully observe and record your observations. If there's a precipitate, this indicates mercury 1 is present. So we should have a precipitate, right? So 6 molar ammonia. This is our 6 molar ammonia bottle. I want you to note ammonia, I know I told you is NH3. Sometimes ammonia is labeled as NH4OH because when I have ammonia and water, it creates, so ammonia, oops, you can't see that. So let me write it down here. Ammonia and water creates ammonium and hydroxide. So that's why sometimes ammonia is labeled as ammonium hydroxide. You can see that. So ammonia plus water give us ammonium hydroxide, which is, that's why this is labeled ammonia, NH4OH, just as a side note. So what do we say? How much? 2 mils. So I'm going to count 40 drops and then I'm going to vortex. Whoa, do we see that? Do we see that black precipitate?
Yeah.
Okay, that's about 40 drops. I saw that black precipitate like after maybe 5 drops. So my observations, I can see that I'm getting a black precipitate and I am going, so that indicates that mercury's present. So this is basically telling us, okay, I've got that precipitate here, mercury's present. I am going to mix it. So carefully observe. So I definitely want to mix it. And then I'm going to centrifuge and decant. So it doesn't say to mix, but we should always mix when we add stuff together, just to make sure that it's always. Okay, so I mixed it. I can just see like a bunch of gray, black, I don't know, stuff throughout. So I'm gonna centrifuge it. I have only about 2 mils in here, and in my balance I have 4. So I'm gonna dump a little bit out. Okay, so this is what it looks like before centrifuging. There's just kind of, I see kind of black everywhere, or dark gray maybe. So I'm gonna centrifuge this. Okay, so it's kind of hard still to see. It's still, because I think a lot of that black is like stuck to the tube. So I think we need to decant, I'm pretty sure, and then we'll be able to see it better. So on step 4, let's see, so centrifuge and decant the supernatant. So I'm still on step 3B. I centrifuged it. I'm going to decant it into a clean tube for further analysis. We're going to keep the precipitate just in case, in this case. So I need a tube, which I theoretically should label, which I can do in a second, but I'm going to pour this here. So this is my supernatant from step 3B. There we go. So now we can see that it's clear and colorless, right? So this is my supernatant from step 3B. So are we good? That was step 3B. So now I'm at step 4. Step 4 says add 6 molar nitric acid dropwise with stirring to the supernatant from step 3B, which I have in my hand, until the solution just tests acidic to litmus paper. Carefully observe and record your observations as the solution is acidified. Okay, so I have some litmus paper. So we need to know that blue litmus paper is what we want to do to test for acidic. Blue litmus paper turns red in acidic conditions. So blue to red, acidic. So I just remember BRA. Blue to red means acidic. So I'm going to take a litmus paper. So please be paying attention because you guys will be using litmus paper. And I'm just going to take 1 strip, and I'm not going to use that strip just once. I can use this strip like 4 or 5 times. I'm going to grab a paper towel, and I'm going to place we should never place anything here. I might, just for purposes of showing you, because I don't know, well, maybe we can get it. I'm going to move this back. So I'm going to place paper towel here with the litmus paper on it. And what I'm going to do is use a clean stirring rod and test my solution. I'm going to dip the stirring rod into the tube and then put that on the solution. Or sorry, put that solution on the litmus paper. So I'm going to actually do that. I'm going to use a Kim wipe because I have it right here. Okay, so there's my litmus paper. let me rinse this off. I want to make sure it's clean. And what am I doing? I'm adding 6 molar nitric acid dropwise with stirring. So I'm going to clean up a little bit. Okay, so here we go. 6 molar nitric acid. I have the right stuff. Here's my tube that I should have labeled 3C or 3B, excuse me, supernatant. And I'm going to add a drop. Put this down so I don't drop it, so I can show you. So here goes in a drop. Don't really see much happening. I saw it go in, didn't see anything. Let's test to see if it's acidic. So I'm using my stir rod, dipping it in, and I'm touching it. Can we see this to the litmus paper back here? Oops. Oh, there, I got some on there. So I don't know if you can see that, so I'm gonna lift it up, and it's at the very end and it doesn't turn red. So that means it's not acidic yet. Okay, so I just touch the tip. So I'm just gonna do little dots and I'm not gonna waste the litmus paper. So I don't wanna use one litmus paper for one test. So I'm gonna add another drop of nitric acid. Okay, I didn't really see much going on. And I'm going to do a dot. And it still didn't turn red. So I'll show you as soon as it turns red. So I'm gonna do that again. Might have saw a little bit of precipitate form. I'm not sure, maybe a tiny, tiny bit. But I'm doing another drop, another spot on the litmus paper, still not red. Okay, still not red. So you got to keep doing it. Just being patient, because if we had too much acid, the precipitate could dissolve. So the precipitate we're trying to form. So that's why we don't want to jump the gun. Doing a drop at a time. Yeah, I kind of feel like I'm seeing a little bit of precipitate form. Not enough to be totally evident. So still not acidic. Still not acidic. Still not acidic, so I'm just being patient, doing drops and testing. Mixing it a bit. Still not acidic. Oh, that time I thought I saw some precipitate, but then it kind of went away because I don't think as soon as it gets to acidic, that precipitate hopefully stays. Or we have to do step 5. So still not acidic. Okay, still not acidic. I'm gonna get another piece of litmus paper. Let's see if you can see. Did you guys see that? The precipitate forms and it goes away. So essentially it's just not acidic yet. There's still too much ammonia in there, and ammonia is a base. So we got to get rid of the ammonia and form ammonium. Should be getting close here. Oh, you can see it forming and going away. It's kind of like a titration. I can tell we're getting closer and closer. Ooh, do you see it on the bottom?
I see it.
Thank you. Yeah, when I stirred, it went away, but it's kind of like a titration in a way, right? I could tell I'm getting closer to the acidic point as it, forms and stays more. So if you want to look carefully here, oh, see, I'm mixing it. Oh, it went away, but we're getting close. So we probably aren't quite acidic enough yet. So close. So patience is the name of the game for a lot of this stuff. Oh, I think it stayed. I think it stayed. Oh, not quite. Well, it's definitely staying. It's more cloudy. Still not acidic. Oh, maybe I got a little bit of purple. So, okay, it's gotta be acidic. I'm guessing it's gonna be acidic now. Yep, I put it there and it turned. Okay, so you could see I was patient. I was carefully observing as I was adding it in. When it wasn't acidic enough, I could see precipitate form and then go away. But now as soon as it's acidic, the precipitate has stayed. So we've kind of taken all the ammonia from the silver. So I took this ammonia from the silver to form ammonium. And now the silver with the chloride that was already in there has formed this silver chloride precipitate. Okay, there was already some chloride floating around the test tube from earlier because I started the experiment by adding HCl. So at the bottom, I can see a nice white precipitate, and that's our silver chloride. So that confirms our silver. So we don't have to do step 5. So step 5 would only be if I got my positive precipitate here, but a negative, like I never got the precipitate by adding the nitric acid. So my last step that I had